Okay, thank you. I will try to tell you a bit about our thoughts or ideas on water and energy. They are intermixed because you need a lot of energy to treat water, and water can also contribute, at least wastewater in certain ways, to energy generation. And I will just share some thoughts about it on the development of what you would call in the end carbon neutral or energy efficient treatment plants. Different terminologies are used. I personally would call it carbon neutral, but energy neutral is also good there. And there are actually 3 points I briefly want to address. I will not go in details. If you're interested, come to me after the talk or later. One is some thoughts about energy minimization, because wherever you think about energy, trying to minimize is the first goal rather than trying to produce, although producing energy might be more glamorous. Then discussion on production of energy, and finally on resource recovery and its integration with energy or carbon neutrality. So energy minimization for utilities, for wastewater treatment plants, has 2 main drivers. One could be just minimize energy and become energy independent from the electricity grid. There could be all kinds of reasons for that. And the other motivation is coming from climate change. You just want to reduce the emissions of CO2, which is of course strongly related to the consumption of energy. But both arguments are used. Sometimes they are mixed, but it's also good to try to keep them a little bit separated. So if you look to wastewater treatment and greenhouse gas emissions, then initially we think very much about indeed energy use and CO2 emissions. But if we go and look at different treatment plants, we will see that there can be a very big variability in the treatment plants and even within one treatment plant. This is just a picture from 3 treatment plants in the Netherlands. 2 treatment plants have no anaerobic digestion, only aerobic mineralization, and they have in the blue effectively only CO2 emissions due to electricity consumption. If you look to the 3rd treatment plant, Kralingseveer, we compare here 2 months in October and February. This treatment plant has anaerobic digestion, and the light blue is the CO2 footprint due to release of methane in the atmosphere. And you see that the release of methane in the atmosphere almost equals the CO2 needed related to the energy production for the treatment plant. So that methane release is very important to recognize if you try to minimize energy by implementing anaerobic digestion and at the same time let methane escape in the air. I'm not sure if that is helping the climate a lot in the long run. And the second compound of interest is N2O. Now in October, the N2O emission of this treatment plant is relatively small, but the contribution in February is almost the only relevant factor. And this is the problem of N2O. It's highly variable, it's not predictable at the moment. And so if you are interested on minimizing climate impact of our treatment plant facilities, we can look to energy minimization, but we should first also look to secondary emissions, methane and laughing gas or nitrous oxide. Now, effectively, in the Netherlands, at wastewater treatment plants, of all the methane which is produced at the treatment plant, 5 to 10% of the methane is emitted in the air. And I can assure you that these plants are well monitored and well operated and well maintained. This is just site emissions which are happening. They can be prevented if you take attention to it, but normally that has not been done in the past. But it's very important to do because it's an important climate change impact. And certainly if you implement anaerobic digestion because of energy, because of climate change, this is a very important aspect. Now the N2O, that's a much more difficult one. There we are still doing research, and that would take a long time to go in all the details, but this is a very complicated process which has not been solved yet, despite maybe some claims here and there. Energy use minimization, we can make new processes. And I will show you 2 processes, one which we developed somewhere around 2000 already in the 1990s. That's the NMOX process. That's anaerobic removal of ammonium from wastewater. That's a very energy efficient process after anaerobic digestion. So if you first have anaerobic treatment, like anaerobic wastewater treatment or anaerobic digestion, then the water contains only ammonia, then it's a very efficient nitrogen removal process. Now, this process is implemented worldwide, mainly for industry and mainly after anaerobic digesters. And it's always nice to remember that the biggest NMOX installation is here in China. It's treating around 11 tons of nitrogen per day for an industrial treatment plant. There is talk of making this process also available for municipal wastewater treatment. Now, bringing NMOX to municipal wastewater treatment itself does not save a lot of energy. It would only save energy if you at the same time can remove all the organic carbon from the water without oxidizing it and bringing it to a digester. And is this step, which is more complicated maybe even than the NMOX process itself, although from academic point of view, the attention is mostly to the NMOX process. If we really want to take this serious, we will have to look very well to the COD capture and bring it to the digester. Technically, there's in principle no problem. We have run at low temperature an NMOX reactor pilot plant. That's the one here on the scheme, on municipal wastewater for a prolonged period. It can operate stable. There are examples from different high temperature countries where it's more or less spontaneously occurring. There's a nice example from the treatment plant Xi'an here in China where more or less spontaneous NMOX has been observed. It is possible, but that COD capturing and concentration is still actually the bottleneck for making it more energy friendly. Now, the second technology that is based on granular sludge, we developed a technology that we understand how we can make bacteria grow in granules. And with that knowledge, Royal Haskoning DHV and also BCC and a few other companies are trying to reach the same. Implement technology, making use of the fact that bacteria grow in granules. The advantage is that you do not need the clarification step because the granules settle so fast that you can do the settling inside the tank. And that means that you need much less pumping energy.